Yep. Good evening, everyone. So, let's start off. Sorry. Come on, everyone. So last class we are doing maximum power transfer theorem. Let's see a question on this and then we'll go ahead. So we have a circuit like this. The battery is 5 volt and internal resistance is 2 ohms. Find R for max power in R. Find R for max power in 3. How do you do that? So we got a battery with an internal resistance 2 ohms. You connected two external resistances, 3 and R. So what should be the value of R so that you get maximum power in R? Find the value of R for the maximum power in 3. Both are totally two different questions. Others, do keep your cams on. What is the first answer? First was straightforward, not this result only. Now be very careful with this, okay? Don't get confused between both of them. So power in R would be 5 by 5 plus R whole square, that is a current, into R, isn't it? This is the current. Total voltage by 5 plus R. So we have to do this maximum minimum, dP by dR equal to 0. And we get here R is equal to 5 ohms. So basically what happens is the 5 ohm thinks, the 2 ohms, R thinks, the 2 ohms and 3 ohms is internal resistance. So from maximum power transfer theorem, because see, how does R will think I'm external, everyone else is internal. Are you getting that? So it will think 3 plus 2, 5 is the internal resistance. There is R is equal to 5. But look at the B part. If you talk power in R in 3 ohms, current will be 5 by 5 plus R whole square into 3. For this to be maximum, denominator should be minimum. Because numerator is anyway constant. Therefore, R should be 0. So be careful. Maximum power transfer theorem we derived for find the value of R to find the maximum power in R. That is maximum power transfer theorem. But if they give you R ka value and if they ask you power in some other resistance, you can't use power transfer theorem. Because some people, what they do, they think like this. This is 3 ohms. This is 2. So 3 will think 2 and R are internal. So R should be equal to 1. Are you getting the mistake? You can't do that. If the question is find the power in R, when R is changing, you can use maximum power transfer theorem. So if you want to find the value of R, when you want to find the power in R, then you can say R is 3 plus 2. I hope you're getting that point. So be careful with that. Easy question, but trap. Check this out. Clear?
So 5 plus R is minimum now.
Come again.
5 plus R should be minimum now.
Yeah, 5 plus R should be minimum. R can't be negative, so R is 0. Reena, Rishi, Kamson, Nanya, Kavish, clear? Krisha, clear, no? Brenda is eating Frankie. Eat. Tips wala Frankie, kya? Home Frankie. Ice cream you're eating. Chalo, carry on. Sunday special. I know, Sundays I'm taking off. You have to bear with me for another 1-2 months. Once we catch up with the portion, then Sundays I'll not take. Next one, let's see the fuse. What is a fuse? I'm sure you must have seen this. It's a safety device. Which disconnects the circuit when large current flows. If you ever brought this thing, this the power supply wala box, you'll find a fuse inside. Let me show you how it looks. In the houses, we use these PCBs which actually trip. But when I was in school, we used to have this fuses. Where is this current? This is how a fuse looks. You can see this thing wire here. This is the fuse wire. So in the house, let's say if there's a short circuit and a large current flows, this wire will melt. Danya, check it out. Clear? So the meaning of this is the symbol looks like this. You can see this in your AC ka, this thing also. AC ka switch ko upar dekho, it will be written 16 amps. You're getting it? So that thing actually can withstand up to this thing. So if you written 10 amps on this thing, the meaning of this is if I exceeds 10 amps, if I is greater than 10 amps, the current, the wire will burn and the circuit gets disconnected. But in houses, we don't use these kind of things. In houses, so we use that PCB which will trip. Wire melts actually and circuit gets disconnected. So the concept is pretty simple. You exceed this current, the circuit gets disconnected. So it is a way of actually trying to save the house equipment. When a large current flows, the equipment will get destroyed. Before that, this will disconnect the circuit. So whenever you want to make a fuse wire, this can be a theoretical question in bits or mains. Fuse is made of a material. Tell me one thing, should you have high melting point or low melting point? Do you want it to melt with low temperature or high temperature?
High temperature.
High
Somewhere
temperature
in the middle.
low temperature na, matlab maybe 120 150 degrees.
So, but then in low current, it will also melt now.
Itna easily temperature nahi badega. You have to produce heat also na. So you want it to be low temperature. You want the temperature to rise as fast as possible, and it should have low melting point and low specific heat. Again, when I say melting point, it will be around 300 400 degrees, right, Shaurya? Normal regular wires don't reach that kind of temperature. Low specific heat capacity. Even for a small heat, you want a large change in temperature, and you want the wire to melt as soon as possible. Socho na, ghar mein big current is flowing in the house. Don't you want it to disconnect it in milliseconds? You let the current flow for 3-4 seconds, pura refrigerator, AC, VC sab jayega. Clear? I still remember when I was in school, 5th or 6th standard, I guess. Normally this plug is there, na? Like this. I took a tongue cleaner and kept it inside these two. And then I switched it on. What happens? Basically, connected to different voltages with a wire, you get a huge current in the house. The wire got burnt. You must have seen, the fuse box. It actually kind of looks like this. There is a rod kind of like this. You can see this for a transformer. Big ones, the white color made they look. You have to, insert them inside. So there is a wire from here to here. So that is a fuse wire. So if that melts, then circuit will get disconnected. So house mein to circuit got disconnected. Power went off in the house. Everyone is thinking, what happened? What happened? I know what happened. So I just came out and I was walking. Oh, fuse guy. I was talking with everyone. I never knew the concept of fuse that time. So my mom came and said, fuse egripoyindi. In Telugu, fuse egripoyindi matlab fuse flew away. So I started thinking fuse must be a bird. It went away. Because of that, we are not getting electricity. And I was wondering how will my mom go and catch the bird now? So that is my imagination about a fuse. I thought it's a bird which gives electricity in the house. I think I was 4th or 5th. I used to do pretty weird things. One time I kept a wire in the switchboard and kept one wire in the mouth. I was actually holding on to a rail, so my hands were not free. I needed to catch with something, so I kept one wire in the mouth, and luckily I switched it on, and luckily because I'm holding a rail, I left it because of the shock and I fell down. The circuit got disconnected. Or else today you wouldn't have your physics teacher. Clear with this? Let's say a question. So basically, fuse the idea is pretty simple. If a current exceeds a certain value, it will get disconnected. So let's say we have a fuse here, 10 ampere. But the resistance is 10 ohms. 5 ampere ka fuse, resistance is 5 ohms. Find the maximum current without burning any fuse. You want both the fuse wires to be safe. So what is the maximum current you can send through the system? Get this.
So can you show that previous sequence?
अभी तक क्या कर रहा था? कुछ है ही नहीं इसमें to see also.
Okay, done.
I told such a big story. What are you doing? You're listening to the story without seeing on the screen. You're the type of person either who can listen or you can write. Yeah. There are few students like this in the offline batch. When you tell them a story, they put the pen down and they listen to you. They stop writing completely. Get this. It's a good one. Easy one, but a good one.
So what is that second value of current?
5 ampere, 5 ohms. 5 ampere ka fuse with resistance of 5 ohms. let's see, what is the catch here? The catch here is, first of all, see, the current does not care about the fuse. Current will think about the resistances. If you say this is I1 and this is I2, we know I1 into R1 should be equal to I2 into R2. So I1 into 10 is I2 into 5. So I1 by I2 will be 1:2 ratio. This ratio is always valid, independent of whatever is the fuse. Fuse doesn't care about this thing. So there are two cases, So let's say case one, if I1 is maximum, if I1 is 10 amps, then I2 should be 20 amps. This is not possible. The I2 will burn. Case two, let's assume I2 is maximum. See, one thing is clear. One of them have to be maximum. See, if I2 is maximum, then I1 is 2.5. This is safe. Therefore, I is 7.5 ampere is the maximum. Easy. When you're asking maximum current through the wire, one of the fuse is having maximum current. Now, which one is having maximum, we don't know. If you assume 10 ampere is having maximum, then 5 ampere mein 20 should flow. If you assume 5 ampere is 5, then 10 ampere mein 2.5 should flow, which is okay. I hope you're getting this. So through this entire circuit, you can send 7.5. If you send more than 7.5, this 5 ampere will blow off and the current will start flowing through the 10. This is a very bad circuit, actually. No one makes it like this. But just for, a conceptual clarity. Do have a look at this. So the maximum current you can send through this system without burning anything is 7.5 amperes. And that 5 will go through the 5 ampere and 2.5 will go through the 10. Please check this out. Ask me if you're confused. Clear? Next one. Try clear with this. Brinda, Shaurya, got this? Hasni, clear? Arishi? Anamai, Dipanshu? Great. Next thing. This is important what you're going to do. So listen carefully. It's not difficult. Just 3-4 formulas and some things, but important. Electrical instruments. So in electrical instruments, right? Technically speaking, we have only one instrument, a galvanometer. The working of galvanometer, we will see in magnetism. How does this work? What is the principle behind it? So basically, whenever a current flows through the wire, it produces a magnetic field which will repel a magnetic needle. And based on that angle, we can find the current. So let's not worry how it works. That full setup we have in magnetism. But for now, simply, it's a current sensitive device where the current flowing through the wire is proportional to the angle deflected. Angle deflected by the needle. Now, why that happened, we will not worry about it right now. But just know this thing: when you send the current, it deflects. So it kind of looks like this. So let's say this is 0 milliampere, 1 milliampere, 2 milliampere, 3 milliampere. So this is 1 milliampere. So you can have reading on both the sides. Depending on which way the current flows, the needle will deflect that way. So if the current I flows this way, the needle will deflect this way. If the current flows from this way, then the needle will deflect this way. So basically it depends on the current direction. But you can make a better, galvanometer where it deflects only in one direction. So this is the symbol for the galvanometer, G. The current is taken as Ig and the resistance is taken as Rg, resistance of the galvanometer. This is the symbol for galvanometer. The biggest problem we have with the galvanometer, it cannot measure large currents. The range of a galvanometer is milliampere to microampere, 10 power minus 3 to 10 power minus 6. It cannot withstand large current. If you send 1 ampere current, the circuit will burn, wire will completely burn inside. So this is the story. In entire current electricity, right? We can only measure, we have only one device which is helpful to us, galvanometer. And the problem with this guy, it can't measure big currents. It can measure current, but it can measure only small currents. So somehow I need to do something, right? So that I can measure big currents and so that I can measure voltages. Are you getting it? So how to convert this galvanometer into something which I can measure large currents or voltages? Let's see how that works. Yeah, it's a current sensitive device. It measures current. Can I turn the page? So listen carefully how it works. If you know how it works, if you understood the construction of the devices, chapter is pretty easy. There's nothing there. You just need to understand how it works. So listen carefully, and we will do some 7-8 questions. You'll get the hang of it. So we have ammeter, voltmeter, meter bridge, potentiometer. These are the 4 things. Meter and there is one more thing. Post office box. There are 5 instruments which we have to see. Today we'll see till meter bridge. Wednesday we'll see potentiometer. So Wednesday we'll wrap up the chapter. So you will have enough time. Chapter went on almost for 2.5 weeks. So capacitors, I hope you must have finished it by Wednesday at least. So first thing, so you understood the problem. We can measure current, but you can measure only small currents. So somehow make something which can measure large current. So we use an ammeter. So we construct an ammeter. So what's an ammeter? It measures current. And constructed. And remember, the only thing you have is galvanometer. With that only you have to make everything. And constructed by shunting. Shunting, meaning keeping in parallel. That is a more technical word called shunting. But you just remember like this, meaning keeping in parallel. Constructed by keeping in parallel by shunting the galvanometer. This is the word they use. I shunted the resistance, I shunted the battery, I shunted the galvanometer. Shunting meaning you keeping in parallel with a small resistance. So you take a galvanometer and you keep a small resistor in parallel. That whole setup is called as a ammeter. Now let's see how that works. So we have your galvanometer. You shunt this with a small resistance. I'll call it R shunt. So if you break open an ammeter, you'll find these two. So this whole setup, this is called an ammeter. So what you want to measure? You want to measure the current in the ammeter. That is this capital I. But what you get in this galvanometer measures Ig. And we know the current divides in the ratio of opposite resistances. So we get Ig will be equal to R shunt by R shunt plus Rg into capital I. So capital I will be Ig into 1 plus Rg by R shunt. In case you're getting confused how I got that, this is I minus Ig. Ig Rg should be equal to I minus Rg into R shunt. You can simplify this, you'll get this. So what we are getting is the galvanometer measures Ig So it is actually measuring Ig, but it shows capital I. Let me show you how that works. So it will always measure Ig, but you have to make the galvanometer show capital I. This is called as calibration, and this is something which we always do. For example, when you stand on the weighing machine, tell me one thing, what does weighing machine measure? What does weighing machine measure? Anyone?
Normal force. Normal
It measures
reaction.
normal force. It does not measure your weight. It always measures normal force. Then what do we do with that? It measures the normal force and divides by 9.8, and that's what you think is mass, na?
Yes.
Weighing machine never shows your mass, never measures your mass. It measures normal, but it shows your mass. This is what we call as calibration. All the devices that we know, right? They do something like that only. They measure something, but they show something else. So let me show you how that works here. You can note down that formula in the red box. You're going to use that. But more than the formula, right? Understand how we got that formula. You kept a resistance in parallel and we did something. Because exam, what they will do? They will say, and galvanometer is shunted, and again it is shunted. Matlab two resistance in parallel. And the last we find the new current car reading. So you should know how to change the construction also. Any doubts on this page, please ask. Clear? No. How does this work actually? Example, when you look at your weighing machine, when you stand on top of it, it actually measures normal reaction. But it shows N by G, which is equal to M. So same way, we have to do something similar here. So in my galvanometer, when the reading now is like this 0 milliampere, 1 milliampere, 2 milliampere, 3 milliampere, and so on till 10 milliampere. So this is actually Ig. So what I will do now, I will erase these numbers and I'll multiply these numbers with a factor Ig into 1 plus Rg by R shunt. Example, if I take 1 plus Rg by R shunt, see Rg and R shunt are, I can choose any value I want. So if I make this 1000, then you know what you get? So we know I is equal to Ig into 1 plus Rg by R shunt. So this will become 1000 times Ig. So on the galvanometer, I'll erase this milliamperes and I'll write 0 ampere, 1 ampere, 2 ampere, 3 ampere. Are you getting what is happening? So when the current in the galvanometer is 2 milliampere, the current in the main circuit is 2 ampere. And what I did, we did smartly, we erased this milliampere ka symbols here and we left only ampere ka symbols. So even though it is actually measuring the milliampere, but you made it show 2 ampere, no? Is this making sense? So this is something I can mess with that reading. For example, if this reading was 500, what will it show? 0, half ampere, 1 ampere, 1.5 ampere, isn't it? I hope you're getting it. By changing the value of this multiplying factor, I can create whatever factor I want. So every time the galvanometer is measuring Ig, but you made it show capital I. Are you getting how you made the device measure larger, a current, even though it can measure small currents? Please understand this. Sometimes they'll use the word full scale deflection, meaning maximum Ig. The maximum current the galvanometer can take is called full scale deflection. An ideal ammeter has zero resistance. Ideal ammeter, but real life ammeters are not ideal. And ammeter has to be in series to the device. So if you want to measure current in a device, you have to keep it in series. Please have a look at this, understand how it is working. So the galvanometer will always measure small Ig. उसमें doubt ही नहीं है. But by adjusting the value of Rg and R shunt, you can get a multiplying factor. So if you can multiply that factor to the Ig ka value, you will get the capital I ka values on the ammeter. So just erase the milliamperes and put the I ka values. So whenever the main circuit mein current is 2 ampere, Ig is 2 milliampere, and the needle will show 2 milliampere. So galvanometer will think I am showing Ig only, but we made it show capital I. Understood how we manipulated the whole thing? Think about it. Ask me if you're confused. So you measure Ig, you show capital I. So by taking a large multiplying factor, if you take a 10,000 as a multiplying factor, you will get 20 ampere, 30 ampere, 10 ampere. See, you're measuring big currents now. Any doubts on this? Clear now, Amu? Ivyanshu? Shaurya? Got this? Kavya?
Yes.
Hasni? Clear? Trisha? Vrinda? Reena? Clear?
Yes, sir.
Now there are a few things you have to keep in mind. So whenever you construct a galvanometer, the R shunt should be very small. Why? Multiple advantages. Number one advantage, the range increases. You can measure larger and larger current. 1 plus Rg by R shunt. This is the multiplying factor. By making a small R shunt, you can get a bigger range. That is one advantage. Next thing, if R shunt is more, Ig decreases. Think about it. The galvanometer, right? If you send more current, it will burn. So if R shunt is small, maximum current will flow through the R shunt. Which is good for us. You don't want maximum current to flow through a galvanometer. So galvanometer is protected. The device is more secure. It doesn't burn out. So you need R shunt to be small. Third, the questions are important. HSC के लिए plus entrance में they'll ask this theoretic questions. The error decreases. What is the error exactly? Think about it. If you have a device and a resistor, ideally speaking, the current should be V by R. But then what you did, since you want to measure the current, you kept an ammeter in series. Now the current actually becomes V by R plus RA. You messed up the current because you wanted to measure the current, right? You kept an ammeter, which itself has a resistance, and you messed up the current. The very act of observing something messes up the observation. Heisenberg uncertain principle. If you actually think about it. For example, let's say Amu is there. She's angry on me and she's shouting on me. She's telling someone, Arun sir, aisa hai, karke. I just wanted to hear what she's saying and I come close by. She suddenly become calm. She'll talk more politely. Did you see? The very act of observing, what she's trying to do changes the observation. Amu, understood now? Clarity idea. So no, this is true actually. I think I told you this thing. Biologists have a problem. How long does a fish live? Simple question. They don't have an answer. You know why? If you take a fish and put it in an aquarium, and if you keep observing it, it will die eventually. So did the fish live longer because you kept it in a protected environment? Or is it that the real lifespan of the fish? Or will the same fish live in a different way in a wild? Chalo, then if you put the fish in a wild, what will happen? You can't observe it. Making sense? That's the problem. So the very act of observing something messes up the observation. That is the whole essence of Heisenberg uncertainty principle. That's what it says. If you can exactly locate the position of the particle because you located it, how do you locate something? You send something smaller than that, right? So when it goes and hits that particle, you know, it is here. But because you're sending something so small, due to the collision, that particle position will change. You got the location, but you messed up the momentum. You wanted the momentum, you'll not know the location. So there is a sacrifice. Anyways, so what is the R resistance here? So 1 by RA is 1 by RG plus 1 by R shunt. So if you keep R shunt is small, RA will be small. So the error decreases. You can't avoid the error, but you can at least decrease it. These are the three precautions. Right?
So can you explain the second point of?
See now, if the R shunt is small, maximum current will flow through this now. So IG will become small, right? Parallel circuits, what will happen? Current will flow more through a smaller resistance. Please take out these three precautions. So whenever you construct an volt ammeter, these are the three things that should be careful. Range, protection, error. This will be a multiple choice question in advance. HSC made the theory part, mains made direct question. Which of the following statements is true? Clear? Now, can I turn the page? So this is how you construct an ammeter. How do you measure voltages? Idea is the same. Again, remember, you have only galvanometer, you have nothing else. So somehow you have to make this galvanometer work like voltmeter now. So voltmeter, it measures voltage. Potential difference actually. Across elements, it has to be kept in parallel. It has to be placed in parallel to the device. Obviously, if you keep it in parallel, you get same voltage. If you keep it in series, you get same current. And how do you construct it? It is constructed by keeping a large resistance in series. So this is how it looks. We have a galvanometer, we have a R large. This is some external resistance. So you want to measure the voltage across this resistance. So this is how this setup looks like. So this R external. This whole setup is called as V. So that G, that R galvanometer plus R large together is called as voltmeter. So if this current is I, this current will be IG. So IG flows through the galvanometer as usual. So the voltage across the galvanometer will be IG into RG plus R large. बस हो गया, direct formula. Check. The voltage across the R external will be nothing but voltage across this thing. I into RG, I into R large. That is a potential difference. I into R. Ohm's law. So the current flowing through the ammeter and the large resistance into multiplied by the resistance will give the voltage. Check it out. So this factor Rg plus RL is a multiplying factor. This is a current in the branch. So Ig into resistance will give you voltage. And since this and this are in parallel, you'll get the same voltage. Check.
Sir, voltmeter has its own resistor.
Yeah. We'll see. Why should I large chart? So in this case, Rg plus RL is your multiplying factor. Don't you want more range? So how does this work? Same idea. Your galvanometer measures Ig milliamperes, 1 milliampere, 2 milliampere, 3 milliampere, and so on. So the voltage you are getting Ig into RL plus R galvanometer. Let's say example, if you take RL plus RG, if you take it as 10,000, then this guy will suddenly become, so till now you're measuring Ig, now you suddenly start measuring voltage, 0 volt, 10 volt, 20 volt, 30 volt, and so on. You're getting it? So whenever the current in the galvanometer is 2 milliampere, the voltage across the device is 20 volts. So you made a galvanometer which measures current to show voltage. So it's all this manipulation of this, the values. So why should R be large? Same reasons. Number one, range increases. If RL is big, you get a bigger range. Second thing, galvanometer is protected. If the resistance is big, current will be less. Ig will be small, therefore galvanometer is safe. Less current will flow through the higher resistance. Third, error decreases. Exactly same reasons. Because if you have a large resistance, when you keep it in series parallel, the overall resistance will not get affected. And ideal voltmeter has infinite resistance. So in the question, if they mention ideal voltmeter, you can take infinite resistance. If they just mention voltmeter, and there are some questions like that, non-ideal voltmeters, you have to consider the resistance. Ideal voltmeter has infinite resistance. Check. So that is how you made a galvanometer who measures small current show big currents and big voltages. Have a look at this. Let's see some questions on this. That's it. These are the 2 theory points there. Clear? Let's see a question. Let's get this. Try. First one is easy. The galvanometer shows some deflection. The deflection becomes half when it is shunted by 20 ohm resistor. What is the resistance of the galvanometer? Again, I tell you now, don't think like a galvanometer, potentiometer, voltmeter. Don't think like that. Simply think of like regular circuits, okay? Simple resistance, simple voltage. It is just regular circuits. If you think that way, you'll get the questions. First, think about it. Try. First one is easy. See, first one is easy. He's saying the current is equal. Now, forget about the resistance, okay? Forget about the name, galvanometer and all. Simply, if the current is splitting equally, both the resistance should be equal, isn't it? If this current is I1 R1, we know I1 R1 should be equal to I2 R2. End of the day, it is a resistance, whether it's a galvanometer or whatever. Current is same, I by 2 into 20 is equal to I by 2 into RG. RG is equal to 20. Kuch hai hi nahi tha. You can just see and tell. Since the current is splitting equally, both the resistance should be same. That's it, done. Second one, what to do? A galvanometer, a resistance of 20 ohms, reads a full scale of 0.2 volt. Now, this is important. Look at the wording. The full scale, meaning maximum voltage is 0.2 volts. And resistance of the galvanometer is 20 ohms. So indirectly, he's giving you Ig will be V by Rg, which is 0.2 by 20, 0.01 ampere. So that is the meaning of this. So a galvanometer maximum voltage it can withstand is 0.2 volts and the resistance is 20 ohms. So indirectly, he said the current in the galvanometer cannot exceed 0.01. Great. Now you want to make this into a galvanometer of 10 ampere. So he gave capital I is 10 ampere, small I is 0.01, Rg is 20 ohms, and you're asking for R shunt. Okay, na direct formula substitution. Capital I is equal to Ig plus 1 plus Rg by R shunt. This guy would be 10, 0.01 1 plus Rg is 20 by R shunt. So this thing you can approximate it, that would be 1000. Approximately equal to 20 by R shunt. So R shunt would be approximately 0.02 ohms. So if you look at the options now, first thing, to construct an ammeter, it should be in parallel. So series wrong, series wrong. So 0.02, no, answer is B. Check. Shunt resistance is always in parallel. That's the meaning of shunt, parallel. Check once. B is a good one. So you have to first find Ig, then use that in the formula.
So
That's
we
the
can
meaning
just
of first
check
case.
with multiplying factors, will we?
कर सकते हैं, but IG कैसे पता चलेगा? That
I
you have to
mean,
find initially.
हाँ, IG find out करके.
Same thing, same thing. Check it out, everyone. It's based on direct formulas, but you should know what you're doing. Go ahead. Any doubts on this page? हाँ ना मैं clear with this. Divyanshu. Clear. Divyanshu. Get this. So we have a 10 milliampere 9 ohm ka galvanometer. There are two resistors, 0.1 and 0.9. If the current enters at A and leaves from B, find the value of I. Get it? Now just read out the circuit now. See, the current doesn't care who is RG. You're getting it. So you have this galvanometer here, whose resistance is 9 ohms, and this guy will be 0.9 ohms. You're connecting the battery between A and B, right? So C will be here, which is useless anyway. C is useless, so this is B. So this is capital I. So what is the shunt resistance here? This would be IG. This is 0.1 ohm. So in this thing, R shunt will be 0.1. Rg will be 9 plus 0.9. And Ig is given as 10 milliampere. He's asking for capital I. Dal the formula mein directly. Are you getting this? This guy will think, okay, I'm in parallel, and this whole thing is Rg, isn't it? The 0.1 doesn't know who is actually Rg. It will simply think anyone in parallel to me is Rg. Hope you're getting it. Can you tell me this thing? What happens if you connect the terminals between A and C? Then what will change?
R shunt would change.
R shunt will be 1, Rg will be 9. You're getting it? So depending on which terminals you're connecting, Rg and R shunt will keep changing. So I is equal to Ig plus 1 plus Rg by R shunt. So Ig is 10 milliamps. 1 plus Rg is 9.9 by R shunt is 0.1. That is 99 into 100. So that is 1 ampere. Easy? Check. Right, Vrinda, Divyanshu. Both of you are right. Please check. So what is Rg? What is R shunt? It depends. You have to see the scenario there. You just blindly write down Rg is equal to 9 every time. You will mess up. The shunt resistor will think whoever is parallel to me is Rg. Clear? Next one. Let's get these two. I'm keeping all these questions together. A galvanometer coil has resistance 90, meaning this is Rg. Full scale deflection 10 milliampere. This is Ig. 910 ohms is connected in series with the galvanometer to make a voltmeter. This is R large. The least count of the voltmeter is 0.1. Least count meaning the smallest measurement you can make. For example, on a centimeter scale, smallest measurement you can make is millimeter. This is the smallest measurement of voltage. So if you look at the D equation, the voltage V is equal to Ig into RL plus Rg. So Ig is 10 milliampere. R large is 910 and this is 90, that is 1000. So which is 10 volt. So the smallest reading is 0.1 volt. So 10 by 0.1 will be 100 divisions. Is that making sense? You can measure 10 volts and each division will measure 0.1 volt. So there are 100 divisions. Easy? Check. Get the E part. Keep going. Like I said, questions are easy, but you should know a bit like, okay, this is what I should think and approach. A little practice, you'll be fine with this. So just don't blindly work up the formulas and go. Get the E part. show you the E part. In the circuit shows the resistance of voltmeter is
So
10,000
can you wait
ohms.
for 1 minute?
Try. Yeah. Let's see. Circuits on resistance of the voltmeter is 10,000 ohms. Ammeter is only 20 ohms. Ammeter reading is 0.1 ampere. Okay. So in this 0.1 ampere is going. Voltmeter reading is 12 volt. Perfect. Then you want to find the arca value. Okay. And this value is 20 ohms. The ammeter value is 20 ohms. Okay. So voltage across the resistance plus voltage across the ammeter should be equal to the voltage across the voltmeter. Isn't it? Because the whole thing is in parallel. This would be 0.1 ampere into R. This is 0.1 into 20 should be equal to 12. The 0.1 into R will be 10 and R is 100. Done. Voltage across this R plus ammeter should be equal to 12. VR plus VA should be equal to voltmeter current reading. And the current in the ammeter is 0.1. So the same current will flow through R also. So 0.1 R plus 0.1 into 20 should be 12. Easy, one-liner. Check. You do get questions like this in bits and mints. Can I turn the page? Let's get these two. Try. 2-3 minutes. First was easy. So you want to prove Ohm's law. What is Ohm's law? The resistance is equal to voltage by current. How should the voltmeter be connected? In parallel. How should the ammeter be connected? In series. यही है ना? Voltmeter is in parallel, resistor is in series. Look at everything else. This is messed up. Ammeter is in parallel, voltmeter is in series. Wrong. Direct था, कुछ नहीं उसमें. Just you should make sure V should be parallel. Ammeter should be in series. This should be in series and this should be in parallel. G is a good question, right? G na, I will change something. See, let's say these four are there na. Arrange the resistances in ascending order. I'm just changing the question. If these four devices are given, ammeter of range 10, 5, voltmeter 5, 10, arrange the resistances in the ascending order. Who has the least and who has the highest? Get this. This is a good one. Try. I'll give 2 minutes. Get the G part. A, C, B, D. Okay. Let's see. Try. Who has the least and who has the biggest? Let's see. First thing you need to understand. Tell me one thing. Between ammeter and voltmeter, who has the least resistance? Among ammeter and voltmeter, who should have the least resistance? Ammeters, right? Ammeter shunt resistance is very small, isn't it? Voltmeter should have large resistances. So for voltmeters, larger the resistance, bigger the range. Therefore, the resistance of D should be greater than resistance of B. For ammeters, smaller the resistance, bigger the range. Both are reverse. That means whoever has more range in ammeter, they should have small resistance. That means resistance of A is smaller than resistance of C. So if I combine all this, and obviously ammeter has the largest resistance, so RA is smaller than RC, is smaller than RD, is smaller than RB, RB, and then RD, ACBD. That is the order. Yeah, Divyanshu, Rishi, you both got it right. Check. So A has the least resistance and D has the highest resistance. First of all, voltmeters have bigger resistance than ammeter. So among the voltmeters, D is stronger. Among the ammeters, the smaller one is the 10 ampere one. Check. Any doubts on this? It's a good one. Have a look at this. Clear? Next one. Let's get these two. Yeah, first was easy. Ammeter should have small resistance. Voltmeter should have large resistance. Did I? See. So the question is, first of all, these are not ideal. In the circuit shown, the readings of the ammeter and voltmeter are 4 and 20. The meters are non-ideal. Perfect. So the voltmeter is in parallel. So it will measure the proper voltage. There's no problem with that. Since voltmeter is in parallel to R, it measures voltage across R. Fair enough. But what is the ammeter measuring exactly? Since the voltmeter is not ideal, you get the current in the voltmeter and the current in the resistance. The ammeter is measuring IR plus IV. Now, so what we got this thing is, this is 4 amperes. That means the current in the resistor is not 4 amperes, it is less than that. And we know the resistance ka value is voltage across the resistance by current in the resistance. So that would be 20 volt by 4 minus IV. And this is definitely greater than 5 ohms. Check. So the voltmeter reading is right, but the ammeter reading is messed up because the ammeter is measuring the current in R plus V. But in the formula, V is equal to IR, V should be the voltage across the resistor and I should be the current in the resistor. If both had been ideal, voltmeter ka current would have been 0. And in that case, the ammeter ka current would have been the current in the resistor also. Since the voltmeter is non-ideal, it is messed up. Please check. It's a good one. The answer is greater than 5. The voltmeter is measuring more current than actually which is flowing in the R. So the I ka value is less than 4. The resistance is greater than 5. All sure with this? So these are the kind of questions you get on ammeter, voltmeter. Not difficult if you see all are 1 to 2 liners, but certain questions you really need to think. Any doubts on this page? Clear? Next one. Meter bridge. So meter bridge is nothing, just a theory. Let's finish off with that. We call it a meter bridge because the wire which we use is 1 meter long. So what is the use of meter bridge? It is to measure resistance using the principle of Wheatstone bridge. Why can't you just use voltmeter and ammeter? Problem is, just now we saw the voltmeter and ammeter will always have errors. So you always get a wrong answers. Just now we saw the last problem. Since ammeter and voltmeters are non-ideal, we always get errors. So we get an error when we use R is equal to V by I. So how does this equipment look like? So we have a metal frame like this with a resistor, metal frame, a resistor. Like this. So this is the thick wire. So this is terminal A. This is terminal B. This is the resistance R, which I know. This is an unknown resistance Rx. So your job is to find that unknown resistance. And what we do, we connect a galvanometer in the middle to this thing. So this blue wire is it's a wire with resistance. The resistance of the wire is R0. Length is supposed to be 1 meter, but let's take it as L. Let the length be equal to L. So this thing which is there, like the tail, this is called a jockey. Basically, this thing, right, it can be moved on the wire AB. You can move that wire on that AB at different points, you can connect it. This is the jockey. So let's see how this equipment works in the next page. But this is the setup. If you are doing any lab experiment, you must have seen this. Have a look at this. Let me show you in the next page. Let's see. Now, how does this work? Idea is pretty simple. You keep moving the jockey till you get a 0 reading in the galvanometer. We move the jockey till we get 0 reading in the galvanometer. When this happens, that is basically the current in the galvanometer IG becomes 0. We say bridge is balanced. So paper may they'll write like this only. The bridge is balanced at X is equal to 20 centimeters. Indirectly saying the current in the central branch has become 0. So if you look at the circuit here, we have R, we have Rx, we have this wire here, we have the battery, and you connected this jockey to this. Ig is 0. If you take this value to be x and this value to be L minus x, tell me one thing, if the current in the central branch is 0 means what? Isn't it a Wheatstone bridge? If this resistance by this is equal to this by this, then the current in the middle branch is 0. That is the whole principle of Wheatstone bridge. So resistance R by resistance of that wire will be R naught by L into X. This is the resistance of AC. Is equal to Rx by resistance per unit length into L minus X. This is the resistance of AB. R naught by L will cancel. We get Rx is equal to R into L minus X by X. Straightforward. So this is a balanced Wheatstone bridge. X ka value I can measure. Substitute there and you get the answer. So indirectly what we're doing is R by X is equal to Rx by L minus X. So what is the so big deal about this? Since the current Ig is 0, even though the galvanometer is non-ideal, it doesn't matter. Even though galvanometer is non-ideal, even if you put a non-ideal ammeter there, if the current is not flowing, why does it matter? It does not create any errors. But then again, you have your own problems. Let's see what are the problems you face in this also. But the setup is pretty simple. You put a known resistance, you put an unknown resistance, you move the jockey on the wire till you get Ig is 0. Then simply R by X should be equal to Rx by L minus X. That is the reason the bridge is balanced. If the current in the central branch is 0, means it's a proper Wheatstone bridge, and you finish it off. Previous page, have a look at this. Others, do keep your cams on. Clear? Have a look at this page, everyone. Questions will be straightforward. They'll give the length and all, and they'll finish it off. And did you observe one thing here? This is independent of cross section of the wire. It only depends on the length of the wire. Yeah, we are assuming the wire is uniform though. This is a uniform wire. The whole wire should be identical. If you mess up with the wire, then the whole thing will mess up. We will not get into that. Experiments we take normally uniform wire. Till here, this is the basic part, but there is something more important. Let's see the precautions. Have a look at this page. Clear? Now, look at the precautions. These things again useful for HSC boards, useful for your lab practicals, useful for JEE mains where they'll have the precautions. Even advanced where you will get questions on this. So the first precaution is the end corrections. So when we are connecting these wires, now you use actually some length. Since we use some length of the wire to connect, the length of the wire is not actually L. Meaning, when you took this on these edges, now there is some wire here like this you connect. So this is called end correction. So they'll give like this in the exam. The right end correction is 2 centimeters, meaning you added extra wire of 2 centimeters. The left end correction is 1 centimeter. The total length is L. And let's say the bridge is balanced at X. Nothing will happen. The only thing you have to be careful with is R naught by L. And this guy would be X plus 1. This would be Rx by R naught by L. L minus X plus 2. That's it. You just have to be adding 1 there and 2 there on the left and right. So the length won't be X, it will be X plus 1. Length won't be L minus X, it will be L minus X plus 2. That's the end correction. The second precaution, the jockey should not be dragged on the wire. If you drag it on the wire will become thin and it will become non-uniform. Maybe 1 time, 2 times is fine, but if you keep doing it, the whole wire will get messed up at the end of the day. Jockey should not be dragged on the wire. It should be lifted and placed at different positions. So whenever you change the position, lift it, keep it at different position and check. The third precaution is the most important one. That was also asked in the exam as a question. Let me show you that. Have a look at these. Clear? The third one. Exam they ask this question. When the meter bridge is balanced, in which section of the wire should it be balanced? The first 1/3, second 1/3, the third 1/3. Meaning, if the total wire was 100 centimeter, should you balance the wire in the first 33 centimeter or 33 to 66 or 66 to 100? In which 1/3 of the wire the bridge should be balanced? Now it feels like it really doesn't matter, but when it comes to error, there is a issues. So let's see what exactly happens there. The meter bridge is more sensitive at the midpoint. But every time it is not possible to balance exactly at the midpoint. That is, I'll show you why it is important. We prefer to balance. So whenever you're trying to balance the resistances, you have to adjust that known resistance also such that you get the balance in the middle. You can't put whatever resistance you want from the known resistance also. That means balance the bridge in the middle 1/3 of the wire. Why is that? So this is R, this is Rx. This was X and this minus L minus X. Galvanometer. So we just now calculated Rx will be R into L minus X by X. So when you calculate the errors, delta Rx by Rx will be delta L minus X by L minus X plus delta X by X. This has to do more with errors. So look at the problem with this. If you try to make X small, if X is small, error is big. If you try to decrease X, L minus X will, the problem is that if X is becoming small, error will be big. That means if you keep it on the left hand side, if you try to make this X small, you get big error. If X is small, or if you try to make L minus X small, so if you say, no, I'll keep the wire here, then L minus X will become small. Problem is both of them are in the denominator. Look at this. The error will blast off in both the directions. So this would be anyway delta x by L minus x. L is constant. This is delta x by x. If x is small or L minus x is small, there are increases. So if you keep it on the left-hand side, if you get close to the left, or if you go close to the right, you get messed up. When L minus x becomes equal to x, you can do maximum minima. X is equal to L by 2, error is minimum. So ideally speaking, if you can balance the meta bridge exactly at the center, the error is minimum. But then again, it's not possible. So we give that much thoda leeway, like, middle 1/3 karke. This was a direct question in the exam. CET level question, bits, mains, direct question can be expected. If the whole thing had been ideal, it really wouldn't have mattered where you balanced. But no matter what, we'll always get an error in X. I hope this precaution was clear. Quite an important one. Check. That's about the meta bridge. Questions on this are really not that big. We'll see them more in the next class. So Wednesday, when we catch up, we maybe do 1 or 2 questions on this meta bridge. We will do the potentiometer. That's slightly more complex, but if you understand the working, questions will be manageable. Shouldn't be tough. So Wednesday, we'll wrap up with the chapter. We'll do that. Okay. So any doubts in today's class? Anything you can ask me? Any more doubts, right? We'll see it on Wednesday. Today we'll not see. So any doubts in today's class, you can ask. Also free to leave. So take care, stay safe, and the test is online till Wednesday night, 11 o'clock. So do make sure to give it before that.